feminists.
And hey, I'm Angie.
Today we're going to do science. And the science we are going to do is reversible and irreversible changes based on temperature.
Rachel, what's a reversible change?
So a reversible change is when we take a substance at a certain temperature and put it into a different temperature and it changes. But when you put it back to its original temperature, it goes back to its original state. Something that we can see every day that does this is water. We know that if we take water and we put it in the freezer, it will turn into ice. But if you take the ice out of the freezer, which was a colder temperature, and put it back into its original temperature, room temperature, it will go back into being water.
So what is an irreversible change then?
So an irreversible change is a little bit more complex. You can take a substance at a certain temperature and put it into a different temperature and it changes. But if you take it and put it back into its original temperature, it's not going to change back. So something that we can see is this egg here. At its original temperature, it's a runny egg. If you crack it open, it will go all over the place. But if you cook it, if you boil this, it will become a hard-boiled egg. But if you take it from that hot temperature, being hard-boiled, and put it back to its original temperature, room temperature, it will not go back into being a runny egg.
So then, what is soda?
So soda is an excellent question. We're actually going to make root beer today. We'll be making soda. Now, it is going to include both a reversible change and an irreversible change. So let's go ahead and make some root beer.
Let's get started.
To make root beer, the first ingredient is water.
2 quarts water. First quart. Second quart.
Thank you. Okay. So the next ingredient is root beer concentrate.
1.5 tablespoons.
Thank you.
Here's a little spoon for you.
Thank you. The next ingredient will be sugar.
1 cup.
Thank you. Okay.
Would you like this to stir?
Yes, thank you. All right. And then we will stir until the sugar is dissolved. So the next ingredient is dry ice.
What is dry ice?
So dry ice is actually frozen carbon dioxide, which means that it is really, really cold. Carbon dioxide is something that's in the air all around us all the time. And as you know, when it gets really cold outside, you don't just see the air freezes. So it takes a really, really low temperature in order for carbon dioxide to freeze. So we are going to need to be extra cautious. We don't ever want to do this experiment without adult supervision. Thankfully, both of us are adults. Okay.
So is dry ice a reversible or irreversible process?
Okay, so that's an excellent point. When we put this dry ice into the root beer that we've just made, it is going to melt. Now, it is not going to melt into being a liquid. It's going to melt by becoming gas. Now, when we put the dry ice into the root beer, the dry ice will start smoking a little bit. It's not actual smoke. That is the carbon dioxide going into the air. But there's also going to be carbon dioxide that goes into the root beer. So let's wait a minute and let's put some carbon dioxide into the root beer, but we're going to do it safely with some tongs. That way we don't touch the dry ice. It's too cold for our fingers.
Ooh.
So Dawson, as you can see, everything that's coming out up here, this is carbon dioxide, and that is evaporating into the air. This is a irreversible process. We can't scoop this stuff up and refreeze it. It's going to become part of the air, and we can't separate it out. Technically, we could separate it out, but we would need a lot of scientists, and we would need some really expensive equipment, and it does not happen naturally. That's how we know it's irreversible. However, all the stuff that's coming out of the dry ice that's actually going into the root beer, as you can hear, all the bubbles, that's going into the root beer. Now, right now, we can hear it as the dry ice is going into the root beer and you're getting your carbonation, because nobody likes their soda flat. But as you know, if you leave your soda out overnight or something, as the temperature goes back to room temperature, which means that it's going to warm up, because right now it's really, really cold, we don't want to touch it with our bare skin, all of the carbon dioxide is going to leave and go back up into the air, just like it is going right now. So that is actually a reversible process. We started originally with root beer. We put dry ice into it, got bubbles, but then the bubbles left, and we will go back to flat root beer.
Is it okay that all of this is escaping? Is it harmful to us?
So it can be a real problem. We do not want to exist in an environment where there's too much carbon dioxide in the air. So what we need is we need the room to be ventilated. Now, thankfully we do. We have an open window next to us, so we know that all the carbon dioxide and the air is mixing, and so we have enough air. Otherwise, that would be a problem. And thankfully, we have adult supervision so that we can be safe. Now, something else that we need to be safe about is we cannot drink this until all the carbon dioxide has melted. If we ingested carbon dioxide by drinking the root beer right now, we could seriously burn the inside of our stomachs and mouths. So, we are going to wait until all the carbon dioxide has melted and either gone into the air or into the root beer, and there's no solid ice left before we actually drink this.
How long does that usually take?
That can take about 10 to 15 minutes.
Okay.
So it looks like the root beer is finished. We don't have any more bubbles coming out, so we know that there's no more dry ice and that we are safe. So why don't we get ready and dig in? All right.
Here you go.
Thank you. So, Dawson, which part was the reversible process?
I believe the reversible process is the bubbles that went in and then they're going out.
Yep. Which part was the irreversible process?
The irreversible process was the dry ice and it melting.
So why is it irreversible?
Because it requires a lot of people and technology in order to put it back in its solid form. It doesn't naturally occur.
Yeah, it doesn't naturally occur. So as it wouldn't ever go back to its original state. So that would be pretty much it for today. Cheers!
Thanks for watching, and if you like this video, please hit the thumbs up, and if you want more content like this, please subscribe.
We'll be making STEM-related videos for kindergarten through 8th grade. Be safe!
And happy Halloween!